Hello, fellow problem solvers. So today we're going to be doing another problem from Pranav's Olympiad Combinatorics. And this one is from the first chapter on algorithms in the exercises, exercise number 4. I invite you to try this problem out for a minimum of 15 minutes, ideally half an hour, but not more than an hour and a half. If on the other hand you'd like to go along with us, just give it a go for the next 10 minutes. Put your first idea out on paper. And now without further ado, let's begin. So, two endpoints in a plane, no free collinear, okay. Possible to pair them up in such a way that the end line segments joining the paired points do not intersect. This is very, very cool. I really like this problem. Because here's the thing. You might think, oh, let's just like pair up the points which are, let's take a point that is closest to each other at every step. But then you would have like this sort of pair. You have this paired, then this paired, then this paired, and then bam, the destruction of everything. That's not what you want. You do not want the destruction of anything, of everything. So how do we do this? Well, there is sort of an algorithmic way to do it. One way I'm thinking of doing this is when I have two endpoints, I think of this like inductively immediately. It's just like, well, let's say I have these points. Well, I can pair them up. Bam, bam, bam. And then I'm given two new points, right? And now it's like, oh no, I have a problem. But do I have a problem though? Do I? I mean, I can also look at this as the same problem, but instead of these, I can look at these 2 points like to the side, right? I can have like these 2 points are on the side, and then I'm applying the inductive hypothesis on these 2 points. So how would we go about doing this? I invite you to pause for another like 5 to 15 minutes and think about how you would write a solution. And now here's the major idea. For n equals 1, you just have 2 points and you're done. And now what I'd like to do is like say we have 2 endpoints. Bam, 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 bam. Great. What I would do is I would just like go to the leftmost part of the plane, whatever that is. Like you give it some orientation. And then just like start drawing these parallel lines until you hit the first point, and then you keep drawing. And then if you've hit another point here, then connect those 2 points. You will not hit a third, and apply the inductive hypothesis on everything else. Now, by the inductive hypothesis, you can pair these up, right? And then these two, when you add them, they're not interacting with anything else. They're not intersecting it with anything. So you are done. You're good to go. However, say you haven't gotten to another point here, you like keep doing these lines until you reach to another point. And now say you reach 2 points. Doesn't matter. Connect them with 1. And then let's apply the inductive hypothesis. This other point will not cross this line segment. So apply the inductive hypothesis here. And again, you are done. And it's just like that. And I think maybe algorithmically, because this is in the algorithms chapter, I think algorithmically you could just say like we're going from left to right, just like moving these lines. And then we're going to connect these points, like order them from left to right, bottom to up, because like some may be on the same line, P1 and P2. And then name these points P1, P2, P3, P4, P5, P6, P7. And then we just say, well, we'll connect P2k minus 1 and P2k for every single k. And this will be valid. Like they will never intersect. Because if, say, 2 points, like say 2 line segments PL minus 1, PL, P2L, and P2k minus 1, P2k, if these intersected, why is that not possible? Well, say this is greater, say K is greater than L. Well, it's not possible because these 2 points are to the, these 2 points are to the right of both of these points, and these are to the left of both of these points. And so we're done. Like, I don't think it's a super deep, you can maybe say like what their Y and X coordinates are, but I don't think you need to here. I think this really solves our problem. And if you have any questions, if you have any ideas, any sort of other suggestions for problems to cover, put them in the comments down below. And as always, thanks for problem solving.